Hello friends, welcome back. Welcome to Ekeeda.
Hello friends, welcome back.
Please join.
Welcome to
Please join Ekeeda for the effective learning of GATE and for getting good score. And use code NAMO10 for getting 10% off from the registration fee. Okay. In the present lecture, let us discuss about the Terzaghi's rate of consolidation. Or let me write it down. Time rate of consolidation. So, and Terzaghi's theory is also called as a one-dimensional theory. So, why it is, we'll discuss in the few minutes. Or, I will also call it as a Terzaghi's experiment. So, in Terzaghi's experiment, so let us keep it aside, or let us understand the concept of consolidation. So, what is meant by consolidation? For a purely cohesive soils, as if it is a completely saturated. Then, if we are applying the external pressure, then because of that pressure, then the voids present in the water may expel from it. In that process, the stress from the water is decreases gradually, and at simultaneously, the stress or the effective stress will increases. So in that process, the thickness of the soil are also changes. That means we can also call it as a settlement of the soil is also occurs. So to understand that behavior, Terzaghi has done some experiment from the depending upon the physical conditions. That is, suppose let us imagine that if there is a purely cohesive soil, so in that what we'll see, we will see soil structure, and also in the voids are completely filled with the water, and also in that we are applying some external pressure. So Terzaghi has done the experiment based on the spring piston model. You can say it as a spring piston model. So the entire process that is understood by using the spring piston model. So whatever the soil particles are there, so those the soil particles are analyzed in the experiment by using the spring system. Imagine that uh, there are soil particles. The soil particles I am just representing with the spring nature. So even though I am drawing in a very regular nature, but in reality they may not happen so. But this is just to represent or to understand the behavior, how the effective stress will vary. Okay, and whatever the voids are there, all the voids are filled with the water. So that's why with all surrounding nature, I will apply or the mud. It will be completely filled with the water, and also there will be some propertical permeability as the water is seeping through the soils. So that process I will consider a piston. So the contact between soil to soil particles, that means the porosity or the permeability nature I am representing with the pistons. So as there is some porosity, I will leave some gaps. Whatever the black shades I am drawing here, those are nothing but a voids or that allows the permeability. So in this nature, suppose if I apply some external pressure, so if I apply some external pressure, then what will happen? Initially, all this pressure can be is taken by which one? Either it is taken by the water or it is taken by the spring. The first thing obvious is that complete stress is taken care by the soil. Sorry, as water is having very high stiffness. Initially, whatever the load that is acting on it, that is completely taken care by the water. So what I will do is that as The water is taking complete pressure. Because of that pressure, because of the drainage conditions surrounding the cohesive soil, the water will expel. As the water is expelling, that means the soil's thickness is decreasing. So here the decreasing in soil thickness, that we will apply here by moving the pistons towards each other. So in that process, what will happen? The spring is getting compressed. So if the spring is getting compressed, then what is, we can understand that spring is taking the extra stress. So because of the permeability, the water has expelling. Because of the water expelling, the settlement is occurs. In that process, the stress is transferring from the water to the soil particles. As the stress is transferring to the soil particles, the effective stress in the water, as the water is gradually expelling from the soil, the stress taken care by, or the pressure taken care by water is decreasing. At the same time, as the pressure is decreasing in the water, the pressure taken by the soil is increases. So in that nature, we can say that gradually, as your water is keep on expelling, the pressure taken by the water decreases, and at the same time, the pressure taken care by the soil particles are increases. That means we can say that effective stress is increases. So but if we add all that, water pressure and the pressure on the soil, if we add all this, that is what nothing but your external pressure. But within the due time, the stress in water is gradually decreases. At the same time, the stress in the soil particles are increases. Okay, now here, what are the assumptions that are considering while doing the, or while deriving this experiment? The first assumptions are nothing but a lies. Or that means if these are not assumed, then derivation is not applicable. So first and foremost thing is that we will assume that our soil is homogeneous and isotropic. Homogeneous and isotropic. So what is mean by homogeneous? In the same direction, all the properties of the soil are same. What is mean by isotropic? At a particular point, whatever the direction you take, the properties of the soils are same. So understand, if homogeneous means whatever the point, but any point you consider, but if you are considering the same direction, then in all the directions your properties are same. Suppose if you are taking that, if your our soil is homogeneous and isotropic, what does it mean? Whatever the point you take and whatever the direction you take, the soil, the properties of the soils are same. And second point is that while the process of expulsion of water, still our soil will be fully saturated, or we can say that soil is always saturated. So what happens, as the water is expelling, the thickness of the soil is decreases. That's it. But within the due time, within all the process of the consolidation, our soil will remains be saturated. And third one, and we can say that uh, the flow, whatever the water is expelling from the soil, that flow is always laminar. So if the flow is laminar, then what we can say? We can say that Darcy's law is valid. That means if, so V equal to K into I. With respect to that, we can find out the velocity. That means if we, your soil is having the unit hydraulic gradient, the velocity of the flow is nothing but a permeability of the soil. By using that, we can estimate the what is the discharge happening in the cohesive soils. And next point is that whatever the strain produced due to the applied stress, that is very small. Why? Because as that, as we are considering that, because of that, there will not be any changes in the soil structure. If that produces the large strain, then there may be a possibility that our entire soil structure of the cohesive soil type may changes. But here we will assume that strain produced strain produced due to applied stress is very small. As the strain is very small, then we can say that the soil structure will not change, or we can say that there is no change in the there is no change in the soil structure. And next point is that the flow is essentially one dimensional. We can say that whatever the flow is happening, that flow is essentially one dimensional. That means if there is a water, imagine if there is a water in the porous medium, that water can move in any direction. But what is the assumption we are considering? That only one dimension. That means, suppose if I consider, let's consider in some, I am considering a soil mass in a cubical way. That means here the water can expel along the width, along the depth, and also along the length. But if I am considering one dimensional, means that the flow of water or the expulsion of water is happening from only one direction, or we can say that that flow is, we can say that that is happening along the thickness. That means there is no change anything along the cross sectional area. So if we are assuming this, then we can say that our flow is one dimensional. So this is what the main important assumption. So, if there is a flow happening along the thickness of the soil sample, then only Terzaghi's one-dimensional consolidation theory is applicable. If you don't assume this, then our whatever the Terzaghi's theory is not applicable here. So, let us write down the equation. So here I'll say that equation for equation for one-dimensional consolidation. So according to the Terzaghi's, it is observed that dou u by dou t, that will be equal to Cv into dou square u by dou z square. So what is meant by u here? Here u representing the pore water pressure, and what is meant by dou u by dou t? Dou u by dou t is nothing but a rate of change of pore water pressure, that is with respect to the time. So here we can say time. That means at the same, the present time, what is the pore water pressure, and after some time what is the pore water pressure, like that. If you want to measure the what is the change in pore water pressure with respect to time, then we are representing with the dou u by dou t. Similarly, what about dou square u by dou z square? First of all, what is the parameter that is representing the z? As we have already discussed that our flow is happening only along the thickness direction. Here z, I will assume that nothing but a thickness of the soil sample. So what is meant by dou u by dou z then? That means it is nothing but a along the thickness of the soil, how your pore water pressure varies. So that is what representing what the dou square u by dou z square. Suppose let us say that imagine there is a soil sample which is having some thickness h. Okay, and imagine that above the soil is also permeable and also below the soil is also permeable. So if both above and below the soils are permeable, then what will happen? The water can expel from the top, and also the water can expel from the bottom surface. So it is obvious that along the sides of the permeability side, the pore water pressure will release quickly. That means, suppose if there is some water particle here, so this have to travel from this point to this point, or it has to travel in the downward direction. So within the meantime, the water already present near to the permeable layer that it might have already expelled. So as the water is already expelled, then we can assume that here the pore water pressure will become zero. By this water has reached to the permeable point. So that's why here dou square U by dou Z square, it is representing the how our pore water pressure varies along the thickness of the soil sample. And here one more very important point parameter, that is nothing but a CV. So here CV will represents nothing but a coefficient of consolidation. Coefficient of consolidation. So it is nothing but a that will be equal to K by gamma W into MV. So here we already know K is a what is the parameter of K we will use in the soil mechanics. That is nothing but a permeability. And what about the term stands for MV? MV is nothing but a which one? Coefficient of volume compressibility. Coefficient of these terms already we have discussed. Coefficient of volume compressibility. And we already know gamma W is nothing but a weight density of the water. Okay, so before moving on to discuss further, here we have to know the term about the length of drainage path. Length of drainage path. So what is the term represent? Drainage. Drainage is nothing but a, what is the term used for drainage? That used to allow the water through it. So what is meant by path? That means what is the length of the drainage indirectly we are saying about it. Suppose as the water is expelling from the soil, there are two possibilities. One is single drainage, or we can say two-way drainage. We can say in that one-way drainage system, one way, or we can say it is a two-way. The name itself we can understand one way, that means the water expelling from the soil from one direction only. From two-way again we can understand that water is expelling from in the upward direction, and also water is expelling from the downward also. Suppose if we consider a soil, imagine the bottom, it is completely surrounded by the rocky soil. So if it is a rock, will it allow any water expel through it? No. So that means in the bottom surface, the water is impermeable. But above, if there is a sand, then there might be a possibility that the water will expel through the sandy soil. So what is the maximum length the water particle is traveled? Suppose if I consider this particle, it will just simply expel it. But if we consider this particle, farmost particle, so if the water, if there is a water present here, how it will expel? It will travel to up to this point, and then they will expel from the soil. So what is the length of the drainage path? So if I consider that if my thickness of the soil sample is h, then what is the length of the drainage here? The largest distance that a water particle is traveled. So here we can say that the length of the drainage path is nothing but h. Similarly, if the top surface is impermeable, if the bottom surface is permeable, then again the water will expel through the bottom. But again the same thing. What is the maximum length that is traveled by the water particle? Again, that is nothing but a h. Suppose if I am considering a soil sample, and imagine that above the surface also it is permeable, and below the surface also it is permeable. If it is so, then what is the maximum length of the water particle that is traveled? So if I consider a particle in middle of the surface, then the particle can travel like this, or the particle can travel like this. So what will be the maximum distance that water particle will travel? So obviously, if h is the total thickness of the sample, h by 2 and h by 2. Suppose if there is a water particle here, so what do you think that will travel in this direction or in this direction? So the water will always expel to the shortest way. So if there is a water particle here, that will always travel to the shortest particle. Suddenly if there is a water particle here, that will travel like this. But if there is a water particle exactly at the middle, that may travel in upward or that may travel in downward. But in both the ways, what will be the length of the drainage path? Nothing but a h by 2. So always remember that If it is a one way, then the length of the drainage path is nothing but a total thickness of the soil sample. If we are having permeability in both the like both top and bottom, that we are calling it as a two-way. So what is the maximum length of the water particle is travel? So here we are representing with nothing but a h by 2. And also we have to discuss one more parameter, that is what nothing but a time factor. So time factor is representing by the term using capital T subscript V. So here time factor is nothing but a CV into T divided by D square. That means, suppose let us say the consolidation has started from 1980. Suppose if you want to analyze at in the year 2020, so what is the time gap between these two? Time gap between these two is nothing but a 40 years. So in these 40 years, suppose if you want to find out what is the settlement happened, otherwise, if you want to find out how much consolidation has happened in the soil, or that means all the soil waters is expelled from the soil, or how much consolidation is pending, if you want to know that, then T is nothing but a time gap between the two. Next, CV, we already discussed that CV is nothing but a coefficient of consolidation, and here D is nothing but a length of drainage path. So as already we have discussed, if it is a one way, then what is the length of the drainage path? That is nothing but a H. That means if there is a one way, similarly H by 2, when we will take, then where there is a two-way motion. And what is mean by TV here? TV is nothing but a sum dimensionless parameter which defines the degree of consolidation. Suppose if your degree of consolidation is less than or equal to 60%, then our value of time factor, that will be nothing but a estimated as pi by 4 into u square. So this is what the standard equation that we have to by heart it for the exam. Wherever, suppose if your degree of consolidation, wherever it is less than or equal to 60, then they need not to mention in the given question. So depending upon the u value, sorry, directly you can find out the time factor from this equation. Suppose if your degree of consolidation is greater than 60%, then your time factor TV, that is nothing but a 1.78 minus 0.93 into log 10 of 100 minus u percent. Yeah, Jagdish Patra, yeah, tell me where you didn't understand. We'll discuss in brief. That means, imagine that and there is a soil, and it is undergoing some consolidation. When we can say that the soil is consolidated, if the excess pore water pressure in the soil is equal to 0. You're asking the pi value, that everybody know, 22 by 7, pi by value 3, 3.14. Pi value is same. Wherever we are writing pi, always the value is same everywhere. Suppose let us say if you are finding the cross-section area of the circle, so what is the formula we'll use? Pi by 4 into d square. What does pi represents? So here we should not take this value in the degrees. We have to take this value in the radians. Imagine you are going to find the cross-sectional area of the circle. So what is the formula you will use if you know the diameter? Pi by 4 into d square. So what does that pi represent? Is it represent 180? No, right? So imagine that the soil is undergoing to some consolidation. Initially, imagine that all the, as we have already discussed, complete whatever the external pressure that is acting on, everything can be taken care by the water. So let us say at that time, let us say it is having some pressure P. So as the consolidation is happening, the pore water pressure will gradually decreases, and at the end of the consolidation, the water cannot take any pressure, and that is taken care by the soil itself. So at the end of the consolidation, what will be my pressure in the water? Equal to zero. So if your pore water pressure is equal to zero, then we can say that consolidation happened completely. Consolidation happened. We can say, I can simply write it on 100%. That means, will it happen immediately, or how much time it will take? So that out to how much time it will take, that we are going to find by using the time factor. That is nothing but a TV is equal to CV into T divided by D square. Suppose imagine that I want to know how much consolidation happen in the soil when my degree of consolidation is equal to 50%. So here what we are going to find, I know how much degree of consolidation should happen. That happen in how many years? So here if you see this, if you are here, this 50% is less than the 60%. So as your consolidation is less than 60%, then directly you can use this formula. Then if you are using this formula, let us say here you are getting some 0.23 or something. So here I can say 0.23. Suppose if we know the soil properties like permeability value and weight density of water, and also if you know the volume compressibility, then we can find out the CV value. And also if our drainage, if whether it is one way or whether it is two way. Suppose if it is a two way, then we have to take our drainage path, that is nothing but a D, that will be equal to H by 2. And also if it is a one way, then we can take it as a H. So then by using this, we can find out what is the time required for the consolidation, or we can say 50% consolidation. Otherwise, suppose imagine that again, if a building is constructed in 2000, and at present now the year is 2020. Now you want to estimate how much consolidation is happened in the present year 2020. So what is the time gap here? Here my time gap is nothing but a 20 years. So here we have to substitute this value, and by knowing we can find out CV, and also depending upon the site condition we can estimate the D value. By this we can estimate the TV. Then if you are estimating the TV, then substituting in this equation. Okay, let us say that now what I want to find, the building is constructed in the year 2000. Now you want to know how much consolidation is happening, or how much consolidation is happened in the year 2020. Okay, now, so what is the time gap between the construction and the at present? That is nothing but a 20 years. And you know the CV value, and also let us see it is a one-way drainage path. If it is a one-way drainage path, how much D value we have to take? H. So by using the relation TV, that will be equal to CV into T by D square. Then we will get some value. Let us assume that if I am getting 0.19, let us say this. What I want to know, I want to know how much consolidation is happening. So what is the relationship between degree of consolidation and the time factor? We can say TV can we find out nothing but a pi by 4 into u square. When this equation is applicable, when your degree of consolidation is less than or equal to 60%. But initially we know the time factor value. But do we know how much consolidation has happened in the soil? We don't know. So if it is less than 60, then we should apply this. If it is greater than 60, then we have to apply another formula. We know the time factor value, but we don't know how much degree of consolidation is happened. Then in that case, first we will assume that your degree of consolidation is less than 60%. So after assuming this, you will substitute in, let us say this is the first equation, this is the second equation. Then you will use the first equation, and you will find out the degree of consolidation. If this is coming after finding some value, if this value is comes less than or equal to 60, then whatever the value degree of foundation we have found out consolidation, that is fine. But if it comes greater than 60, then really is the first formula applicable? No. So if it is like coming less than directly 60, okay, no problem. We have already used the equation. But if it is greater than 60, we have used some wrong equation. So in that case, we have to use the second equation and then find out the degree of consolidation. Okay, this is how we will find out. If we know the time gap, then we can find out the how much degree of consolidation is happened. Or if we know the degree of consolidation, then we can say how much. Likewise versa, we can do it. Okay, let us talk about the degree of consolidation. How can I find out degree of consolidation? So degree of consolidation I can find out either by using the pore water pressure, or I can find out by I can find out by using the settlement happened in the soil, or I can find out by using the void ratio. So we can use different depending upon the known data, we have to use the corresponding equation. Suppose let us say that ui is nothing but a initial pore water pressure, initial pore water pressure. Or let us say that let me tell you with respect to the values. Let us say that there is a soil and some external pressure is happening. So initially, it is observed that my pore water pressure is nothing but a 100 kilopascals. After some time, I have observed that at time t, I have observed that my pore water pressure is equal to 40 kilopascal. So initially, what is the pressure there on the soil? 100 kilopascal. After some time t, what is the pore water pressure? 40 kilopascal. Understand how much pore water pressure is reduced. Okay, how much pore water pressure is expelled. Depending upon the expulsion of water, how much pore water pressure is reduced. So how much it is reduced? Reducing is nothing but a 100 minus 40. If I want to write down in terms of the equation, I can say ui minus u. Here I want to find out with respect to the percentage. So if you want to say that your consolidation is completed, then what will be your pore water pressure? That should be equal to 0. So whatever the initial pore water pressure, if that expelled, if that is released completely, then we can say that your degree of consolidation is happened completely. So what is the reference value we have to consider if you want to find out the percentage? ui. So if you want to find out the degree of consolidation with respect to the pore water pressure, then you have to say initial pore water pressure minus pore water pressure at time t divided by initial pore water pressure multiply by the 100 if you want to get it in terms of the percentage. If you want to get in terms of the decimal, then don't multiply by the 100 value. Okay. And suppose let us say we will find with respect to the settlement. Suppose by somehow we have observed that the settlement is happening in the soil, let us say SF, is the total settlement, or I will simply write it as a consolidation settlement. That means if consolidation is happened completely, so SF is the settlement is occurred in the soil. So at some time t, if I observe that my settlement is happened is S, let us say if complete settlement consolidation is 10 mm, at some time t, how much settlement is happened? Let us say it is 4 mm. How much it should happen for the complete consolidation settlement? 10 mm. But at some time t, how much it happened? 4 mm. Then how much settlement is occurred? 4. With respect to value 10. So what is the degree of consolidation? It is nothing but we can say S divided by SF. Again, if I multiply by the 100, I will get the value in terms of the percentage. If I don't multiply by the 100, I will get the value in terms of the decimals. Okay. So this is what with respect to the settlement. So let us find out the degree of consolidation with respect to the void ratio. Okay. Now let us say at the initial time. So at the initial time, that means immediately after the application of the pressure, will there be any Consolidation, no. So that's why at the initial stage, or else I will write it down. I will write down with respect to the percentage. If I write it down E0, that means the void ratio at 0% consolidation. That means indirectly I am telling you that initially after the application of the loading, what will be the void ratio of the soil particles? That is nothing but a E naught. Similarly, I will say E100. What does mean by E100? 100 represents a 100% consolidation. That means if consolidation is happened completely, so after the complete consolidation, what will be the void ratio present in the sample? E100. Then what we have to find out? We have to find out the degree of consolidation in between initial and final. If you know the time gap, then what is the degree of consolidation? So here nothing but a u percent, that will be equal, we can say E0 minus E divided by E0 minus E100. So always remember that if consolidation is happened means the gap between the soil particles are decreased. That's why our void ratio after consolidation is lesser value compared to the initial stage. So that's why here it is E naught minus E100. Why? Because E naught is the, we'll have the large void ratio in the initial stage comparison to the final one. Okay. So E naught we have already discussed at 0% or initial stage void ratio. E100 nothing but a, if consolidation is happened completely, what will be your void ratio? Suppose what is meant by E then? That means at time t, whatever the void ratio present in the soil sample, that we have to find out. Then we can use this relation. So if you know the pore water pressure, then also you can find out. If you know the settlement, then also you can find out. If you know the void ratios, then also you can find out. It's entirely depending upon the data given in the question. So whatever the data they will give us, that we have to use and we have to estimate the required solution. Okay. Now let us say, or let us understand the equation, that is TV, that will be equal to CV into T divided by D square. Okay, what is mean by T here? T is nothing but a time required, for U percent. That means if for a 60% degree of consolidation, how much time is required? For 30%, how much time is required, like that T. Let us say at particular consolidation, let us say that if I'm going to evaluate at my degree of consolidation is equal to 40%, at U equal to 40%, can I find out time factor or not? As it is less than 60%, I can say my time factor, that is nothing but a pi by 4 into U square. Now, what I will do is that at one time, what I will do is I will keep my length of the drainage path is one way. On the second time, I will say that my length of the drainage path is two way. So here I want to study that if there is a one-way path, one-way drainage path for the 40% of the consolidation, how much time is required? And also I'm going to compare it with if there is a two-way drainage soil, then to get the 40% consolidation, how much time is required? So I want to compare these two. In both the cases, what I am taking? I am taking that my degree of consolidation is same. If my degree of consolidation is same, then what is the constant? My TV is equal to constant. Then what about the C value? If I am taking the particular soil, then my CV is also constant. So what are the variable parameters here? I can say that this is also constant, this is also constant. Then I can say time required for the consolidation is directly proportional to the D square. That means what is D? D is nothing but a length of the drainage path. That means if we are having more the drainage path, then the time required for the same consolidation will be increases, isn't it? Suppose if this is lesser value, then time required for the consolidation is decreases. So if you compare, if it is a one way, what is my degree of consolidation? Sorry, what is my length of the drainage path? H. If it in two way, what is my length of the drainage path? It is nothing but h by 2. So which one is the least value? One way or two way? The lesser value you are having for two way in comparison with the one way. So the time required for the consolidation for the two-way drainage path is will take the lesser time in comparison with the one way. So let us find out the relationship. So I can say T1 divided by T2. I can say that will be equal to D1 divided by D2 whole square. T1 is nothing but a time required for the one-way consolidation, and D2 is nothing but a time required for the two-way consolidation. So if it is a one-way drainage path, then what will be my D1 value? That is nothing but a H. If it is a two-way, what is my drainage path? That is nothing but a H by 2. Now substitute here. T1 divided by T2. That will be equal to, for D1 it is H, for D2 it is H by 2 whole square. So if H's gets cancelled, then 2 square 4. If it's go to the numerator, then we can say T1 will be equal to 4 times the T2. That means, let us say that for the 40% consolidation, for example, for the 40% consolidation for two-way drainage path, if it is taking 10 years time, for the same degree of consolidation, how much will be taken for one-way drainage path? So that is nothing but a 4 times. So for two-way, if it is taking 10 years, for one-way how much time it will take? It will take the 4 times of that. 4 times of the 10, that is nothing but a 40 years. So compare it, 4 times it will take the larger time in comparison with the one way, in comparison with the two way. So if your thickness of the soil sample is also the larger, then the time required for the consolidation will also be increases. Okay, so this is what about the Terzaghi's one dimensional consolidation. Okay, thank you.